All right, lesson 4, we're going to do some word problems here. We also want to clear up creating any linear equations that we may need with the word problems, or just making an equation from 2 points or a slope and 1 point. So lots of stuff going on this page. It all kind of works together. Excuse me. All right, skill 1. Given 2 points or a slope and 1 point, find the equation of the line in the point-slope form and also in the slope-intercept form. All right, there's reason for 2 different forms. One is what you need to have to make the other form sometimes, okay, depending on what the points are. So we want to make sure we understand the slope formula. This is the way we'd label the points so we can use the slope formula. That's really the only thing you can do when you are given 2 sets of points. We did that in the warm-up. And then you want to be able to use that slope with one of those points in the point-slope formula so you can solve that and get your slope-intercept form, okay, which would give you the y-intercept as well, all right? Then right here it says, for word problems, form 2 ordered pairs with the information given, okay? Learn to recognize when you are given word problems with 2 sets of information which you can turn into 2 sets of ordered pairs, okay? So you can find the trend, so you can find the rate of change, so you can, which is another word for slope, okay, given this information or this data that you get. Can they be represented by x is the number of something and then y is the total or the yield, total yield of something? That's usually how that works out, because the slope is the rate of change in those numbers. If you are given so many of these items as information, and then it costs this much to either make them or purchase them or whatever that is, that's your x and y's. It could be it costs this many for this many minutes on your phone bill. It could be miles per hour in your car. You go this many miles. It costs this much to fill up your tank. All kinds of different things that can be in practical everyday use. So we want to notice that our x and y units are not going to be the same, and that's how we're going to line them up, though, in our points. Okay, we're going to do a couple of those. And then once you get that, you're going to use that slope that you find in the point-slope form, so you can change it then to the slope-intercept form, okay, to answer the questions. So let's try one of these. In isolation, let's just do this one. It's out of context. We don't know what these numbers are, but what we can do is label them, that's a y, so we can put them in the slope formula. Okay, I decided this is 0.1 and this is 0.2. So the slope formula is up here, so it's y2 minus y1 over x2 minus, oops, that wasn't y, hang on, okay. Sorry, looking right here, y2, negative 1, minus y1 is a negative 7, sorry about that. And an x2 is a 3 minus an x1, which is a 2. All right, so that's negative 1 plus 7, by the way. That's 1, so that's 6 over 1. That's a 6. That's my m. All right, that's my slope. So what I want to do is, see, it says write the equation of the line, so that's just m so far. So how do I find b? I want to put it in this slope formula. I mean this point slope. I'm going to use this x1, y1 over here. Put in a negative 7 for the y1 equals the slope, which is 6. I'm following this thing right here, right? X minus, and my x1 for that problem, that ordered pair I was using was a 2. All right. So this is going to be y plus 7 equals, let's go ahead and distribute. And then to get it in slope-intercept form, I want to move this 7 over. So y equals 6x minus 19. That is the line of the equation that both of these ordered pairs went through. You can check that by putting them back in. Let's say put the y back in over here for the point 2. 6 times 3 minus 19. That's 18 minus 19. I'll give you a negative 1. That works. Okay, so that's the answer right there. That's the equation of the line that has those 2 points that go through that have a slope of 6. Okay, they have a y-intercept of negative 19. All right, so let's put something in a context here for a word problem. In 2006, Erica's custom design business had 27 customers. Her business is obviously growing with 41 customers in 2013. So we have 2 dates and we have a number of customers. So the number of customers down here, if I keep reading, it says let x equal the number of years after 2000. So that's the number of years, number of something. That's the number of years after 2000, and y equals the number of customers, the total number of customers you would have in those years. Good business planners know their rate of growth per year, so they can estimate future expenses to keep up with demand. Write an equation in slope-intercept form that models her growth, right? Because they want to know and plan for the future of their business, if it's growing fast enough, if it's too fast, prepare materials and that kind of thing. So X is the number of years after 2000. So 2006, they had 27 customers. In 2013, they had 41 customers. There's your ordered pairs. Okay, there's your X1, Y1. X2, Y2 to find the slope. So 41 minus 27 over 13 minus 6. Let me put that in the calculator real quick. 41 minus 27. 13 minus 6. Just to make sure I'm not messing anything up. So that's a slope of 2 per year. That makes sense. And then it says the equation of the line. So I need the y-intercept. So how many did she start with when she started her business? So put the slope in the point slope form with one of the points. So y minus 27 equals 2 x minus 6, right? That's y1, x1, m, right? We're following this right here. And then we want to distribute and then move the 27 over so we get the slope-intercept form. There's your slope of 2, right? And then your B or y-intercept is what, 15? So if things don't change, that is her growth rate. You can put any year past 2000 in, so you can figure out how many customers she would have in 2025 or something, right? You put a 25 in for X, crunch it out, and it'll tell you how many customers she'd have if the growth rate didn't change, okay? All right, number 3 says write an equation in slope-intercept form. Here's the slope. There's the point on the line, x1, y1. Given a slope and 1 point, I need the point slope form. So y minus the y1, and then the slope, x minus the x1, which is a minus. So that's going to be y minus 5. That's 2. X plus 1. So that's going to be y minus 5 equals negative 2/3 x minus 2/3. And then we want to add 5 to both sides. So our final answer is going to be y equals negative 2/3 x. Sorry, there's not a lot of space going on here. How do you add 2/3 plus 5? Well, 5 is how many thirds? That's 15, right? So 2 minus 15 is 13, plus 13 thirds. Don't be afraid of the fractions here, okay? That's the slope-intercept form of that line. All right, number 4 says taxi charges $5 for any ride, plus $1.65 per mile. Per mile means a rate, right? It increases at a rate of, so that's a slope. Let y be the total cost of the ride, and x be the number of miles. So 1.65x plus 5 would be the slope-intercept form that models the cost of a taxi ride. So you can put any mileage in for x and find out how much the ride would cost you. Okay, so that's the answer to that one. All right, the town's population has been decreasing over the years. In 2090, the population was that, and it's losing on average this many. So that is the rate that is declining, okay? And the taxi cab was increasing by how many X you had. If the town's population is going down over the years, you're losing 1,200 per year. Losing, as in subtracting, that's a negative slope, okay? Write the equation of the line that models the decline. Y represents the total population. X represents the number of years since 2090. Find the population in 2012. All right, so 2090 is where they start. So that means this population is the start number. So this is going to be the rate in front of the x, right? The slope or the rate in front of the x. Y is the total. It's going down 1205 per year, and it started at 47,235. So that's the equation of the growth, or the lack thereof, or the decreasing of the population over time. And then 2012 is how many years? 2012 from 1990 is what? 22 years? So negative times 22 plus 47,235 equals a y of 20725. Let me check that in the calculator. 1205 times 22. Alright, and we're subtracting that from 47235. 20725. Yep. That would be how much the population went down by 2012. If it keeps going at the rate that it's decreasing at the rate that it's decreasing. Okay. Alright, last one. Shop owner bought a piece of equipment for $1,500. The value of the machinery declines per year. Declines per year. That's the rate, negative 150 per year. V is the value after so many years, and it was started at 1,500. That's the start date. Because think about it. If when X is 0, you just purchased it. It is worth $1,500. You just purchased it, okay? But over the years, it's going to decline in value. It's going to depreciate, okay? So to write off the equipment depreciation, how much is it worth in 5 years? That's an X of 5. So put that in there and crunch out the math. 5 times it's going to go down this much each year. So 5 years, 5 times. So negative 150 times 5 plus 1,500 gives you 750. So in 5 years, this piece of equipment is only going to be worth $750. Okay. After how many years does it become worthless? Well, it sounds like another 5 years, right? Let's find out. Value would be 0 when it becomes worthless. So we're going to be solving for x to find out how much it's worth later on. So we want to subtract 1,500 from each side. And you're going to have negative 1,500 minus 150x. Divide both sides by negative 150. And that's going to give you your mathematical support for your idea of 10 years. Oops, sorry, that's a 10. Okay? Thank you.